the horizontal lux that a person gets, our maximum horizontal lux is about 613 lux versus 391. So the variation is pretty standard right across the room, and the ratio between the vertical and the horizontal lux, we're almost 60% compared to, let's say, 50% with a standard direct lighting system. Okay, and finally, from the floor, looking down on the floor, we can see there's about, if we're just looking down, we get about 25%. This graph talks about how many lux we're giving as a time of day, and basically we try to do something, a rough color temperature of the light, and how many lux we are getting at 490. Okay, so you can see we're trying to vary. So at this point, so the blue line is the lux basically that we are getting around for our 490. The red line is the CCT value, and the black line is the regular lux for vision. Okay, so you can see as we start in the morning, early morning, we have more lux for vision and less lux for trying to tell the person, that's telling our daytime. As day goes on, this switches. So by noontime, we're trying to get as much lux as we can into telling the time of day, and so much more than the regular photonic lux. As it gets later in the day, this lux drops very rapidly, the amount of lux we're trying to tell for people what time of day it is for circadian rhythm. So we're trying to vary both this ratio throughout the day. And at the same time, this is our color temperature. According to the Alzheimer's Society, old age people cannot accept color temperature higher than about 7,000 K. So we are working to try to make sure that we keep this, we'll be lowering this so it stays below 7,000 K at the maximum time. So this would be, Okay, so how else are we trying now to deploy this, and how we're trying to try to test? We are still currently applying for IRB, slow process in Taiwan, very slow. We are also working with Resin Gardens and the Canadian Alzheimer's Society in Canada. So I want to show a little bit about this collaboration in a second, and this is at McMaster University. This is a quick introduction. I would like to, hopefully we have audio, I hope. Yes, no, I don't know.
Dynamic lighting. Changing the intensity and spectrum of light throughout the daytime, and also to use LED strip lighting in a cold. This will allow us to do indirect lighting. We have many, many light sources, and this will mean no glare, no shadows. So our design is LED strips. We're controlling the emission at 480 to stimulate melatonin. We're allowing our adrenal control, get the flux and the spectrum change, and we're changing it on a 24-hour lighting algorithm. So if the person wakes up at night, they'll get light that's not going to tell them it's daytime. Where we're implementing it, we're trying to work here with McMaster University and Resin Gardens to try to demonstrate it and learn here in North America. But we're also trying to introduce it in a home care environment with work in Taiwan with the Taoyuan Hospital, and in a long-term care environment with the military hospital I was just talking about.
So we're also trying to work with Banqiao, to work with. And so this is the CEO also of the Alzheimer's Society talking a little bit about Resin Gardens and what they're trying to do in terms of demo rooms in Canada. We are hoping to set up 10 long-term care bed rooms with this lighting and a lighting system from Germany, by Philips. We're trying to vary color temperature for comparison purposes. Resin Gardens, the goal of it is it's no longer going to be a long-term care home, but that's connected with the Alzheimer's Society, and everyone coming into the long-term care home realizes they have to sign permission that they will be accepted for research. So that before they come into the home, they will have signed a permission for people to do research on them in terms of lighting or whatever other modern technology research, so you don't have to get consent each time. So the Alzheimer's Society will look after the IRBs. They can grant the IRBs themselves, and people coming in will automatically sign the disclaimer before they are allowed to enter into this long-term care environment. So I think this is an interesting way in which it can progress to try to allow us to do research at a faster rate than trying individual cases, which seems to be very challenging for us here in Taiwan. Okay, this is just talk a little bit more talk, but I'm not sure we get the how's the volume is good. This is.
Welcome to the Wrestling Garden demo room, Mary. I'm happy to welcome you here today.
Thank you, Ken, and I'm delighted to be here.
Well, we'd like to start with a few questions just about your role and where you're coming from today.
My role is
So this is the president of our Alzheimer's Society. But we can then she'll talk a little bit more about the room. I don't see if we can get by our volume. No. So some of the stuff they're working at here, she's explaining, is the mattressing. They're trying to do mattress design to make it, that are trying to work, some people doing research in mattress design to make sleeping easier. There's our Yangtze University logo stuck in the corner. So they call it the living lab. And so the other technologies. This is our lighting beam. So their whole goal here in the Alzheimer's Society is that technology that they develop here, they'll be able to transmit right across Canada for using it in our Canadian long-term care system. So I appreciate their vision. Okay, I think I'm out of time. So I quickly want to mention key people doing research. One is Jeanette White. She's a clinical associate professor, Department of Surgery. Her expertise is eyes and the eyes, light in the eyes. Nafia, he's in Resident Gardens, he's a mechanical engineer and electrical engineering. In Taoyuan General Hospital, Dr. Li Wai Kyung, who's helping us. We are hoping in Taoyuan Hospital to do the outpatients work to try to install in people's homes. So before they go to long-term care, that we can actually intervene before they get into a long-term care environment. And finally, Professor Xu in the Department of Mechanical Engineering. He does a lot of work. We're hoping to help his work in terms of determining whether lighting is actually going to be useful and how useful it is, to try to quantize how useful it is in terms of improving sleep. Okay, that's...
Is there any question for Professor?
Interesting. One question for you. What you mentioned that people, there's still some negative. I mean that there's some people research they also say no to this solution. So what is the point they have?
What is in...
The only one published publication in 2020.
Paper published in 2020. Basically, I believe, my own opinion is that it's their own clinical study, and I believe there's some problem in their research methods. In their research study, what they basically did was they changed this peak and this peak in their control group. They put this peak very high in blue light, and this peak very low. Then they put this peak very high and this peak very low,
and concluded there is no effect of lighting.
It's not that the 490 meters.
Yeah, that's the problem with this
It's
stuff.
always the same.
Yeah, so that's what I feel is the problem.
Open nexus, they have this mistake.
Because I don't know.
That's-
Yeah, but that's so their statement was increasing the blue light does not help. But I think they probably have realized, because I see their group is